The To-Do or Teamwork Makes the Dream Work is a project of the SciTech Mathematical Society, the official mathematics club of Santa Rosa Science and Technology High School. It is a project that aims to provide support to high school students in their respective mathematics subjects. This project consists of distribution of reviewers by grade level and posting of tutorial videos on YouTube. The topics in the tutorial videos are those that are requested by the SciTech students that responded in a survey given by the club, while the topic in the reviewers covers all the topics discussed in the quarter. The reviewers are only exclusive for the SciTech Mathematical Society club members.
Hello, good day. I'm Zander Candido from Grade 2. I'm a representative of SMS and I'm back again for this video. And today I'm going to be discussing about proving congruent triangles. So we have the contents of this video. We have proving congruent triangles, which is the first part, and defining the different properties of triangle congruence and its examples. And second part, as usual, we have the exercises if you learned something. Okay, we have the first part, we have the proving congruent triangles. Also, we have additional theorems. We have the AAS or angle side congruence theorem. If two angles in the non-included side of one triangle are congruent respectively to the two angles in the non-included side of another triangle, then the two triangles are congruent. Here we have the figure. In figure 1, given that triangle DOG is congruent to triangle CAT, we have angle D is congruent to angle C. We have angle G congruent to angle T as marked, while line segment DO is congruent to line segment CA, tells the congruence of the non-included sides. The proof of this theorem is presented in example. Next, we have the hypotenuse acute angle, or HYA congruence theorem. If the hypotenuse and an acute angle of one right triangle are congruent to the corresponding hypotenuse and an acute angle of another right triangle, then the triangles are congruent. This theorem can be applied to right triangles only. Figure 2 at the right shows two right triangles, triangle RGA and triangle MSA. The hypotenuses, line segment AR and line segment AM, are congruent as marked. Angle RGA and angle MSA are congruent because they are right triangles. Angle GAR and angle SAM are acute angles, and angle GAR is congruent to angle SAM because they are vertical angles. Using these congruent parts, the two triangles are congruent by HYA congruence theorem or hypotenuse acute angle congruence theorem. The proof of this theorem is shown in example. Next, we have the HYL or hypotenuse leg congruence theorem. If the hypotenuse and the leg of one triangle are congruent to the corresponding hypotenuse and the leg of another triangle, then the triangles are congruent. Again, this theorem can be applied to right triangles only. As shown in figure 3 at the right, triangle USB is congruent to triangle ARC. Line segment US and line segment AR are legs, and line segment UB and line segment AC are the hypotenuses of the given triangles. Line segment US is congruent to line segment AR, and line segment UB is congruent to line segment AC as marked, while angle S is congruent to angle R because both are right angles. The two right triangles are congruent by HYL congruence theorem or hypotenuse leg congruence theorem. Proof of this is found in example 5. Next, we have the LA or leg acute angle congruence theorem. If a leg and an acute angle of one right triangle are congruent to a leg and an acute angle of another right triangle, then the triangles are congruent. In the two triangles in figure 4, line segment GU and line segment RA are the congruent legs as marked, and angle M and angle P are congruent acute angles as marked, and angle G is congruent to angle R because both are right angles. Hence, line segment GU and angle M are congruent respectively to line segment RA and angle P. The two right triangles are congruent by LA congruence theorem. The proof of this theorem is shown in example 6. Next, we have the LL or leg-leg congruence theorem. If the legs of one right triangle are congruent to the legs of another right triangle, then the triangles are congruent. In the right triangles in figure 5 at the right, line segment AB and line segment OC are the longer legs, while line segment BG and line segment CP are the shorter legs of the right triangles. Line segment AB is congruent to line segment OC, and line segment BG is congruent to line segment CP as marked. Hence, we can conclude that the two legs of triangle BAG are congruent to the legs of triangle COP. So, triangle BAG is congruent to triangle COP by LL congruence theorem. The proof of this theorem is shown in example 7. Next, we have the different properties of triangle congruence. We have the reflexive property of triangle congruence. The reflexive property of triangle congruence states that any shape is congruent to itself. Example, triangle WAY is congruent to WAY itself. Next, number 2, symmetric property of triangle congruence. The symmetric property of triangle congruence states that order of congruence does not matter. If one figure is congruent to another, then the second figure is also congruent to the first. For example, if triangle WAY is congruent to triangle GOD, then triangle GOD is congruent to WAY. Next, we have the transitive property of triangle congruence. The transitive property of triangle congruence states that if two shapes are congruent to a third, they are also congruent to each other. Example, if triangle WAY is congruent to triangle GOD and triangle GOD is congruent to triangle LIT, then triangle WAY is congruent to triangle LIT. Next, we have the median of a triangle. A median of a triangle is a segment with endpoints on the vertex of a triangle, the midpoint of the opposite side. For example, y is the midpoint of line segment AA. KY is the median of triangle KAE. Thus, line segment AY is congruent to line segment YE. Next, we have the equilateral triangle. Equilateral triangles are triangles with congruent sides. For example, if triangle KAE is an equilateral triangle, then all of its sides are congruent to each other. For example, triangle line segment KA is congruent to line segment AE is congruent to line segment KE. Next, we have the segment bisector, a line, ray, or segment which cuts another line segment into two equal parts. For example, line segment KY is a segment bisector of line segment AE. Thus, AY is equal to EY. Next, we have the angle bisector, a line, ray, or segment which cuts an angle into two equal parts. For example, line segment KY is an angle bisector of angle K. Thus, measure of angle AKY is equal to the measure of angle EKY. Next, we have the perpendicular bisector. Segments that form right triangles. For example, if line segment KY is a perpendicular bisector, then angle KYA and angle KYE are right angles. Next, we have the examples. We have the given line segment SL and line segment AE bisect each other at B. So we have the midpoint B. Now, we have to prove that triangle SAB is congruent to triangle LEB. We have the statement number 1. Line segment SL and line segment AE bisect each other at B. That for the reason that it is the given. Number 2. Line segment SB is congruent to line segment LB and line segment AB is congruent to line segment EB for the reason that it is the definition of segment bisector. Number 3. Angle SBA and angle LBE are vertical angles. The reason is that it's the definition of vertical angles. We have typo. This is the number 4 for the reasons supposed to be 3, number 5 supposed to be 4, and number 6 supposed to be 5. Next, number 4, angle SBA is congruent to angle LBE. For the reason is the vertical angle theorem. Angle SAB is congruent to a triangle SAB is congruent to ang triangle LEB. For the reason it is the SAS postulate. Next, we have the given angle 1 is congruent to angle 2. Line segment MR is perpendicular to line segment RA, and line segment VN is perpendicular to line segment NA. A is the midpoint of line segment RN. We have to prove that triangle MAR is congruent to triangle VAN. First statement, we have angle 1 is congruent to angle 2 for the reason that it is the given. Number 2, we have a line segment MR perpendicular to line segment RA. Line segment VN is perpendicular to line segment NA for the reason that it is a given. Number 3, angle MRA, and angle VNA are right angles for the reason that it's the definition of perpendicularity. Number 4, angle MRA is congruent to angle VNA for the reason that it's all right angles are congruent. Number 5, A is the midpoint of RN for the reason that it is the given. Next, line segment RA is congruent to line segment NA for the reason that it is the definition of midpoint. Triangle MAR is congruent to triangle VAN for the reason that ASA postulate. Next, we have the tips about proving congruent triangles. Writing proofs about triangle congruence can be done using the two-column form. The proofs include the diagram/drawing. This is very important so that you can analyze, plan, and decide what postulates or theorems to apply in proving. 2. The given. This is the statement taken from the hypothesis. Number 3. A statement to prove. This is taken from the conclusion. Number 4. Statements and reasons. This portion of proof includes statements supported by valid reasons arranged logically from the given statement until a conclusion is derived. Next, we have the last part of this video, which is the exercises. The directions are: complete the following proofs. Choose your answer from the box below. Write it on a separate sheet of paper. You can answer this exercise after watching the video or review this video first before answering this exercise. And that is all. Thank you. Uh, and as always, I will see you next time. Goodbye.